Quick math test. If you save exactly $1,000 every year for 10 years, what is the total? $10,000. Most people can solve that equation in under a second. But the same mental reflex that makes that math easy creates a blind spot. It makes it difficult to recognize how wealth is actually built over time. We are biologically wired to expect progress to move in a straight line. However, the mathematics of wealth follow a different rule. They grow in exponential curves. This mismatch causes many to abandon sound financial strategies. They see a flat line in their account balance and assume the strategy has failed, right as the underlying math is beginning to work in their favor. This initial period, the first 10 to 15 years of investing, is often called the boring decade. It is a phase where account growth feels localized and uneventful. You contribute thousands of dollars through consistent effort, but the year-over-year gains appear modest. The work of saving feels disconnected from the actual financial reward. Our brains evolved to seek immediate, proportional feedback. We expect that an equal unit of effort today should yield an equal unit of output today. Feeling discouraged during these early years is the natural result of a linear brain misinterpreting an exponential environment. To understand why the curve eventually steepens, we have to look at compound interest as a mechanical system driven by two opposing forces. On one side is your money, the principal you contribute. On the other is the money's money, the interest generated by previous gains. For the first decade, the principal does the heavy lifting. You are manually dragging the balance upward, while the interest remains too small to move the scale. By year 15, the accumulated interest reaches a critical mass. It begins to generate its own momentum, and the scale shifts. At a 7% return, the investment grows to nearly 4 times the initial amount by year 20. The exponential jump becomes undeniable. The boring phase is the fueling sequence. A foundation must be built before the mathematics can support this level of rapid acceleration. Moving the takeoff point closer to the present requires manipulating the variables of the math itself. Automating monthly contributions force feeds the principal base. Since new money drives growth in the early stages, increasing the base gives the interest a larger surface area to compound on later. Optimizing for higher returns, such as equities, changes the trajectory. Even a few percentage points of difference will drastically steepen the angle of the curve in the final years. Shifting from annual to monthly or daily compounding also adds speed. This increases the frequency at which interest is reinvested, bending the growth curve upward sooner. This same math works in reverse with credit card debt. A balance left alone begins to double and then quadruple until the interest payments exceed the ability to pay them back. Whether the curve is working for or against you, the challenge remains the same. Humans are not naturally equipped to perceive exponential changes while they are in the flat, uneventful phase. This slow then fast logic applies to any system where today's output becomes tomorrow's input, from the compounding effects of our daily habits to the accelerating feedback loops in our global climate. If we can't see the curve until it's steep, what else are we ignoring because it's still in the boring phase?